Mr. Bullock here. This Algebra 2 lesson is evaluating and graphing polynomial functions. Okay, let's go ahead and begin. The polynomial function is of the form of this, where they just decrease in exponents. X to the n, x to the n minus 1, x to the, it just keeps going down, 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 all the way x to the 1. And then this is a constant like plus 7 or minus 11 or some number, a constant right there. Okay, and then this a to the n and this a to the n minus 1, they're just different terms right there. They're like, numbers. They're also numbers. So, okay, so this first term, it can't be 0. Okay, and the exponents are, that should be r, you guys. The exponents are whole numbers. Whole numbers are 1, 2, 3, 4, 5. Actually, 0 is a whole number also. And n is the degree, so this first guy is your degree of the polynomial. We discussed that back in chapter, I forgot what chapter, but earlier we discussed that. And this is what's called my leading coefficient. The number that's in front of the degree person is called your leading coefficient, okay? So decide if each is a polynomial, and if so, write it in standard form, okay? Here's 4 of them right here, all right? And then state the degree and the leading coefficients, okay? All right, so here's number 1 right here, okay? This is a polynomial right here. The degree of this guy is 4. The leading coefficient is 1, because there's a 1 right there. Okay, and this is already written in standard form because it goes in descending order of exponents right there. Okay, so that one is a polynomial right there. Okay, this one right here is also a polynomial. It's not in standard form. Okay, pi is just a number, you guys, just like this imaginary 1 right here was just a number right here. So the leading coefficient is equal to that pi right there, and to put it in descending order would have to be pi x squared and then plus the 7x, and then root 3, you guys, is just a number, so minus root 3. So it has degree 2. The leading coefficient is pi. Okay, this one is not a polynomial because this exponent is not a whole number. Okay, this is not a polynomial because that exponent is not a whole number. It's a variable. Okay, so neither one of those are functions. Okay, they're not functions. Okay, so they're functions. I'm sorry, blah blah blah. They're just not polynomials. Okay. All right, so use substitution to evaluate f of x that equals negative 3x cubed plus x squared minus 12x minus 5, and we're going to substitute in x equals 2 right there, right there, and right there. All right, so when we do that, as long as we do everything correctly, I'm going to go ahead and do the exponents first. 2 cubed is 8, 2 squared is 4, so it's negative 3 times 8 plus 4 minus 12 times 2. I just did the exponents. Now I'm going to multiply, okay, and then you add them all together and you get negative 49. All right, synthetic substitution, and it's going to be shown by an example. Okay, you haven't seen this yet, so go ahead and copy that down. Okay, and this is my example. I'm going to show you how to do synthetic substitution. Okay, the first thing you got to do is slide down that negative 3. Then you multiply this negative 3 times the box number, and it goes right here. So negative 3 times 2 is negative 6. So negative 6 goes right there. Okay, then what I'm going to do is add these two numbers. So 1 plus negative 6 is negative 5. Okay, and then I'm going to go again. Negative 5 times the box number is negative 10. So I'm going to put negative 10 right there. Okay, and then I'm going to go ahead and add these two guys. Negative 12 plus negative 10 is negative 22 times the box number. So I get, looks like a negative 44. And then I'm going to add these two guys, so I get a negative 49. This is the same problem as we did in section C right there, okay? Where these numbers, this negative 3, 1, negative 12, and 5 were these numbers right here, and this was my box number right there. Okay, so once you get used to synthetic substitution, you guys, it goes pretty fast, and you're less prone to make mistakes like you are right here. A lot of people would make a mistake with this guy right here. Okay, you get the same answer right there, so do that with this guy right here. Use synthetic substitution to evaluate this polynomial when you plug in x equals negative 2. Okay, now you got to be careful. There's an x to the 4th term there, there's an x cubed there, there's an x squared there, but there's no x's. You have to put in a 0 for the x's, you guys, because it's got to be in descending order. Otherwise, you guys won't make the correct answer right there. Okay, slide it down, and then times the box number. So slide that down, times the box number, okay? Add those two guys together, you get 0, times the box number. 0 times anything is 0. add 3 plus 0 times the box number is negative 6, add 0 plus negative 6 times the box number is 12, add negative 7 plus 12, answer is 5. Okay, I would get 5 if I plugged in negative 2 right there, right there, right there, and it would get me negative 5. Okay, synthetic substitution is great. Okay, this is going to take a little bit, you guys. End behavior. Okay, end behavior is described like this, you guys. If your degree is, if your leading coefficient has a degree that's an odd term right here, then it's going to look like this. If your leading coefficient is positive, think a slope. It starts down here and goes this way of a line. If your leading coefficient is negative, then it goes like that. This is when your degrees are odds. Okay, when your degrees are evens, you're either going to have a touchdown, okay, with both hands in the air, or it's going to be an upside down touchdown right there. Okay, this is when the leading coefficient is positive, it's going to be a touchdown. When the leading coefficient is negative, it's going to be an upside down touchdown. And this is when your degree is an even term, like x to the 4th or x squared or x to the 6th. They'll all end up going, it starts up here and does some, up and down, and it goes up here. How many up and downs does it have? It depends on what the degree is. Typically, this would be a 4th degree. Typically, you guys, it has, whatever your degree is, say it's n degree, it's n minus 1 humps. So if this is a 4th degree, notice there's 3 humps. 1 hump, 2 hump, 3 humps. Okay? Notice this one is a 2-humper right here. So this would be typically a degree 3 term. It could be a degree 5 term. It could be a degree 7 term. This could be a degree 5 or 7 term also right there. So whatever your degree is, it has n minus 1 humps, or 2 less than that, and then 2 less than that, and then 2 less than that. So say we had something like f of x equals something x to the 11th. It's either going to have 10 humps, or 8 humps, or 6 humps, or 4 humps, or 2 humps, or no humps. Okay? So let's use some of that right here. And your end behavior, you guys, is this. As x goes to negative infinity, so imagine if I kept going this way, x is a left and right movement. So if I go this way to negative infinity, y is your graph, how far it goes up or down. Y goes to negative infinity over here. As x goes to positive infinity, this graph is going up to infinity. Over here, as x goes to negative infinity, this one's going up, so y goes to positive infinity. As I go to the right forever, x goes to positive infinity, this graph goes to negative infinity. Okay? So as x goes to positive infinity, f of x goes to negative infinity. That's what that says. Okay? This one is this. As x goes to the left forever, to negative infinity, f of x is going down to negative infinity. Okay, so as x goes to negative infinity, f of x goes to negative infinity. As I go to the right, as x goes to positive infinity, f of x is going to negative infinity. Okay, x goes negative infinity, y goes positive infinity. X goes positive infinity, y goes positive infinity. All right, let's try some of this, you guys. Let's graph this function right here. Okay, so you probably pause it to write it down, otherwise this video is going to take too long. Okay, so when I plugged in negative 3, either by synthetic substitution or just substitution, you get negative 24. And I just did substitution. I didn't have enough room up here to do synthetic substitution. But I get, I'm sorry, it's a positive 24. Darn it, that should be a positive 24. And it is on the next slide. I'm pretty sure it is, you guys. Okay. Let me backspace. Okay, so so when I graph these guys, here's the rest of them right here. It's going to go, these are the rest of them right here. So I'm not going to graph negative 3, 24. I'm not even going to graph negative 3, negative 12, because I don't have enough room right there. But I'm going to graph that middle bunch right there. Okay, here's negative 2, 3. Here's negative 1, 4. I'm sorry, negative 1, negative 4 is down here. Here's negative 2, 3. Here's a 0, negative 3, 1, 0. Here's 2, negative 1 right there. Okay, and let's look at this. This is an odd degree, and the leading coefficient is negative. Okay, so an odd degree is going to be, it's not going to be a touchdown or a negative touchdown, an upside down touchdown. When it's an odd degree, it's either going to go start down here and go up when it's positive, or it's going to start up here and go down when it's negative. Okay, degree 3, typically it's going to have 2 humps, you guys. Degree 3 will typically have 2 humps. So here it is, looks like it's going down. If you think of negative 3, 24, Negative 324 is way up there somewhere. So it's coming down like this, coming down. Looks like it's going to go little hump right there and start heading back up. There's one hump, another hump right there, and then it goes down to the 3, negative 12 right there. So it's going to be a graph that kind of looks like that. Okay? All right, and then your end behavior of this guy, you guys, is x goes to negative infinity, y is shooting up to positive infinity. As x goes to positive infinity, y is going down to negative infinity. And they might say f of x instead of y. Okay, let's try this one here. Okay, this one's going to be a touchdown or an upside down touchdown. It's going to be a touchdown because it's positive. Okay, and x to the fourth tells me probably 3 humps, but it might have 1 hump because 2 less than that. Okay, so let's go ahead and plot these points. When I cranked them all out, I got all of these right here. And then I'm going to only plot those minimal ones right there. Okay, so I'm thinking of a touchdown with 3 humps, you guys. So it's going to be going, and then look, here's negative 212, so it's going to be up here, and then negative 376 is even farther up, so it's going to come down. Okay, and then it's going to have to go back up to catch this one. So there's 1 hump, and then 2 humps, and then it's going to go down, down, down. Remember, a touchdown, so it's going to go 3 humps back up. Okay, so it's going to be a graph that kind of looks like that. All right, so the end behavior is that as x goes to negative infinity, y goes to infinity, or f of x goes to infinity, your book will say. As x goes to positive infinity, f of x also goes to positive infinity. All right, and if you're in my algebra class, I would assign that for your homework. All right, thanks for hanging in there, you guys.